heard what a computer thinks like. So when you get this question, sometimes you may think something like this. And as you can see, this is something quite old, something 50 years ago, and over these years there has been quite a big advancement. So it was a few years ago, and I was impressed by a Japanese software which was called Rocaloid. And here's the short demo video. So Rocaloid is a software that enables any computer to sing in natural human voice, and any user can use this software to create their own music. And so you can see this is very amazing, but I just wondered if we ourselves can create this kind of software and make it even better than existing ones. So we're going to support Chinese and maybe other languages in the future, providing users more features, such as more flexible control over the voice. And it is free as in freedom. So I named my software as Rocaloid, and started 4 years ago. This is a challenging project in its nature. And when I started it, I was just a middle school student who was 13 years old in grade 8. And I was just an amateur in programming and haven't ever learned about audio signal processing. But well, ignorance can also be an advantage because I didn't even know how difficult it's gonna be. So, what is Rocaloid? Our vision is input the lyrics and the music score. The software generates music voice, and concretely it analyzes the data of the input, and this analyzes the input, extracts data from the voice database, and finally it synthesizes the singing voice. So my initial idea was really simple, and you know, almost all languages are composed of very fundamental segments. So for example, the word segment itself, it can be decomposed into segment. So those are syllables, are fundamental particles of a word. And if I can pre-record these segments, store them into a database, and write a program to join these segments automatically, and then I can get a singing voice. The next question is, how do you change the duration of a segment? So look at this. By observing some voice waves, I found that the voice has such a natural periodic structure. So if I can also write a program to analyze these periods and copy and repeat these periods, then I can change the duration, extend the voice, and also do further manipulations. So this is amazing. But such a simple idea took me a year to write the program which performs these operations. And here shows the database I created, and here are some code written, and also it's going to show how the software runs like and it sounds like. So this was my initial attempt, something 2 years ago, and it's very primitive and the sound isn't very good because I didn't have a good enough pitch shifting method, so the voice became quite sharp, and as you heard. But I still think there must be some way to improve this thing. So I searched on Google, and it was really a big surprise to me that, look, I found thousands of papers, journals, academic conferences around speech synthesis. And there has been countless researches around this topic, singing voice synthesis. So if I plot them here, each red dot represents the discovery made in the past. And now I'm gonna label what I discovered by myself in green dots. So look. Well, it seems I have a lot to learn. So I opened some of the papers and it came into my eye like this. Well, pretty daunting, so especially this symbol, now I know it's called sigma, and I used to be completely baffled by this guy. And after skimming through some papers, I found a particular term that occurred the most, which was called the fast-forward transform. So what is this stuff? When you open a music player, sometimes you see this kind of spectrum. And this is produced by fast-forward transform. And this is a kind of analysis tool that is particularly useful in audio applications. So I set fast-forward transform as my initial target to learn. And after several weeks studying, searching, and calculating, and during which I self-taught some chapters in my mathematics book, and finally, I made it. I implemented my first program capable of performing this transform, and now I get the little green dot here. So this is a great motivation to me, and I spent the whole summer holiday learning from these papers, reading a lot of papers. And at the end of summer holiday, 2 months later, I built a small program like this. Well, okay. And so I drag in a sound file, and I'm gonna set up some parameters and play it. So this one's then I change some parameters and play it again. So this simple application is able to change how sound sounds like. So this application gave me the confidence to continue my Rocaloid project. So together with some friends, we started the second round of development, and here's some design graphics showing the structure of our new program and our new algorithm. So in the next 3 months, we wrote 20,000 lines of code and we sampled a new database. And now it eventually starts to make a sound. So this is much better than last time. But the failure came just after success. So a few days later, we found that the synthesis engine becomes unstable during pitch changes. And later when I learned more, I knew that it was a bug in the very basis of our program. And unluckily, this bug cannot be fixed. So we had to throw all of this existing code, this 20,000 lines of code away, and look for some completely new solution. And what I learned throughout this project is, even if you fail, you can still start a new round. And if you can do better than last time, you're approaching your target, no matter how many times you fail. And also, it's worth mentioning that we need to stand on the shoulders of giants. Otherwise, we always reinvent the wheels. So what came later was another round of learning. And I actually found it's not so hard to teach yourself this stuff if you have a clear target and believe you can make it. So this short video shows some of my researches and studies carried out earlier this year. And this is how I analyze some sound file, and this is about synthesis. And here, this is a spectral model of the voice characteristics. And from March to August this year, we wrote another 20,000 lines of code using a completely redesigned algorithm. So here how I wrote the code, and there are 20,000 lines of that. So now our synthesis engine is about to finish, but it didn't have a graphical interface yet. So we also searched on the internet, and we found one called Wutabu, which is a music editor. So we combined Wutabu with Rocaloid. And on August 5th this year, we finally released our synthesizer. And here is my development team. Thanks to my team members. Without them, I cannot get this project done. So in this final video, I'm going to show how Rocaloid sounds now. Thank you very much.
感谢浩凯如的梦想是能让机器人像人类一样歌唱，我们相信他的梦想一定可以成真的，对不对？